Good evening, friends. Study with Apala, Engineering, Geology, Parvin Singh book. Chapter 2nd, The Earth. The core. It is the innermost concentric cell of the Earth as concluded from the records of seismic waves. Its existence was suggested by R.D.'s Oldham's in 1906 and subsequently is confirmed by other seismologists. The core boundaries begins at a depth of 2,900 kilometer from the surface and it's extend to the center of the earth at 6,371 kilometers. So further studies of seismic waves with a special reference to core indicate that the core itself can be distinguished into two distinct zones, the outer cores and the inner core. The outer core comprises the region from a depth of 2,900 km to 4,580 km below the earth surface and behaves more like a liquid because the S waves from the earthquake shock reaching these zones are not transmitted through these zones at all. It is the characteristics of S waves, also called shear waves, that these are unable to travel through liquids. The inner core, with a thickness of around 1790 kilometers, is believed to be a solid metallic body. Much variations in composition is also suggested for the materials lines between the outer core and the inner core, but nothing can be said conclusively. Very significant very significant variations is the density of materials immediately outside and inside of the core are suggested by seismic observations. At the base of the metals density is inferred as 5.7 g per cc, that jump into 9.9 g per cc is at the top of the core. This values reached a figure of 12.7 g per by cc at the boundary of the inner core and becomes 13.0 g per cc at the center of the earth. As regards the chemical composition of the inner cores, the hypothesis that it is made up chiefly of iron and nickels has found support from many accounts. Seismologically, the velocity of P waves recorded in the core bears close resemblance to those records for nickels iron alloys and others non-seismological grounds suggesting to nickel's iron core of the earth are the high density of the earth as a planet, and it is fairly established that the mean density of the earth is 517 g per cc. The density of the rock of the crust is put at 2.7 g per cc. The density of the materials of metal is also calculated to range from 3.3 to 5.7 g per cc. Hence, also calculations suggest a density of 12 g per cc for the materials of the core. This density is comparable to alloys of nickel and iron. So the composition of meteorites are considered to be the wandering of fragments of planetary matter. So most of these are made up of ferruginous composition, with iron being an important metal in them. So in fact, three types of iron bearing meteorites have been studied: hexahedrite, octahedrite and antazite. So hexahedrites, these have a nickel content of 5 to 6.5%. Octahedrite, in these nickels content varies from 6.5 to 16%, and antazite finds grained in natures and contain nickels in still higher proportions. It is argued by many that the iron meteorites are actually fragments from the core of a planet or planet-like bodies of our solar system that has suffered disintegrations during the process of evolution of solar system. As such, the core of our Earth can also be assumed to have a similar composition. The final picture of the internal structure of the Earth is summarized in a general way in figure 2.8. So don't forget to make a diagram with labeling. It is important for every exams examiners give a best mark in this type of figures. So don't forget to make a figure. Internal structure of the earth, diagrammatic, not to scale, average 5.51 g per centimeter cube, density g per centimeter cube 16 12 6 4.2. This inner core, outer core, inner mantle plastic, and this outer mantle solid crust, mantle core, and 900 to 2900 kilometer, 5000 150 kilometers, 6371 kilometers. So make our diagrams proper systematic. Thank you. Like, subscribe and support this channel. Thank you.